To graph a piecewise-defined function, graph each piece separately. Each function will only be graphed on its given interval. You can graph each expression of a function by using a table of values within the interval, or by graphing the entire expression and identifying the portion that is within the interval. So let's look at graphing f of x equals 2x plus 4 if x is less than or equal to 1, and negative x plus 3 if x is greater than 1, stating the domain and range using tables within the interval. So the first thing you want to do is you want to look at the first part, 2x plus 4, if x is less than or equal to 0, or to 1, sorry. So we're going to make a table, and that means that we're only going to be looking at values of x less than or equal to 1. So 1, 0, negative 1, negative 2, negative 3, etc. 1 and smaller. So we create that table, and we plug in 1 for x, solve it, get 6, put in 0, get 4, etc., etc., etc. And then we plot those points onto our graph, and we create our line. Next, we do the same thing for negative x plus 3 if x is greater than 1. So we're starting at 1, and we're using numbers bigger than 1, so 2, 3, 4, 5, etc. Then we plug in 1 for x and solve it. We get 2. Plug in 2, we get 1. Plug in 3, we get 0, so on and so forth. And we plot those points and create our line for that. Now notice here that we have a solid dot at the top of this one and an open dot at the top of this one. That's because for this part of our function, x is less than or equal to 1. That means this is part of our domain for the top part of our function. Over here, the open dot, x is greater than 1, strictly greater than. That means that 1 will not be part of the answer for this. It's not part of that domain. So the domain is going to be all real numbers overall. The range is x less than or equal to 6. So it never goes higher than 6. Let's look at the other method, graphing each line for the given domain. We're going to look at 2x plus 4 if x is less than or equal to 1 first. You can use any method that you want for graphing the line. You graph it out there, and then you remove any part where x is not less than or equal to 1. So here's where x is equal to 1, and you just erase it. Just chop it off. It doesn't exist anymore. Then you do the same thing for negative x plus 3. We graph it using whichever one we want, and then remove any part of the graph where x is not greater than 1. So anything less than 1. So here we find that x of 1 right here, and then we just erase all this extra stuff there, and we have the graph of our piecewise defined function, the domain being all real numbers still, and the range being y's less than or equal to 6.